Hello everyone, today's daily Leetcode problem is problem 1823, find the winner of the circular game. It's a medium problem and there are several solutions we can do for this. So there are n friends that are playing a game. The friends are sitting in a circle and are numbered from 1 to n in a clockwise order. More formally, moving clockwise from the ith friend brings you to the I plus 1th friend for 1 smaller equal to I smaller than n, and moving clockwise from the nth friend brings you to the first friend. The rules of the game are as follows. Start at the first friend, count the next k friends in the clockwise direction, including the friend you started at. The counting wraps around the circle and may count friends more than once. The last friend you count leaves the circle and loses the game. If there is more than one friend in the circle, go back to step 2, starting from the friend immediately clockwise of the friend who just lost, and repeat. Else the last friend in the circle wins the game. Given the number of friends n and an integer k, return the winner of the game. We can see how this game works more clearly through the examples that they provide. So here n is equal to 5, so there are 5 friends sitting in the circle, and k is equal to 2, meaning every second friend basically has to leave. So first we start at 1, we count 1, 2, friend 2 leaves, and then we go to 3, and then we count 1, 2, friend 4 leaves, and then we go to 5, 1, 2, friend 1 leaves, and then finally we end at 3, count 1, 2, friend 5 leaves, and we are just left with 3. So the winner here is 3. And then there's a second example where it's n equals 6 and k is equal to 5, and the logic is the exact same, and you'll find that the winner is friend 1. So when we first want to think about the solution to today's problem, we got to look at the constraints. The constraints are pretty low. So n is smaller than or equal to 500, and k is smaller than or equal to n. And of course, they're both positive. So because n is smaller than 500, this does allow for an n squared solution. And we can just, that means we can just solve this naively by simulating the circle. So for example, if we have a queue, we do q is equal to dec, and we can first put in all the friends, or I for, or it's gonna, yeah, okay, for I in range. So what this does is it first puts k people into the queue, right? And the reason I did I plus 1 is because in the for loop, I is going to start at 0 and end at n minus 1, whereas in the actual friend group, everything's going to be 1 index, so everything should be incremented up by 1. So we can just do that, and then we can do while, or sorry, yeah, let's do while q, or while length of q is greater than 1. Because if there's only one person left in the queue, then that person's the winner. We can just return that person for the answer. So while length of q is greater than 1, and then now we want to simulate cycling through k people. So here it would actually be actually the easiest way to do this would be to go through k minus 1 people and then delete the first person. So I'll just show you what I mean. We do what for I in range k minus 1. So this loop is going to loop k minus 1 times. We can do q dot append q dot pop left. So what this basically does is it simulates popping the current friend from the queue and then adding it to the back of the queue. And that's basically what's happening when, for example, let's say for here, let's say k is equal to 3 instead, right? So when you're at 1, 1 is at the front of the queue. You pop it with pop left, And then since 1 isn't the friend that you're removing, you put them back in the end of the queue. So then you move on to 2, and now 2 is at the front of the queue, and 1 is at the very back of the queue. So then the queue would go 2, 3, 4, 5, 1. And then you do the same thing for 2, because in this example, k is equal to 3, right? So then we pop 2, and then put 2 at the back. And then we move on to 3. So then 3 would be the friend that we actually want to remove. And so we want to make sure to not do this action. So that's why I have it loop at k minus 1 at times. K minus 1 times. And then, so for the kth friend, we just simply pop left. And yeah, we don't add them back. So now we can simply return q0 because that will be the last friend. And let's see if this works. Yeah. Yep. Okay, it does work. But as you can see, it's very slow. Okay. The reason why this solution works and it's not very fast for the current constraints is that this is an n squared solution. So the outer loop, this queue, you can think of it as each time you go through the queue, you remove one person, right? So that means that in total, this loop would have to run n times to remove n people, or like n minus 1 times to remove n minus 1 people, which is on order of n. And then for the second one, k is constant. So okay, it would actually be nk times, or O of nk. But because of that, because k is also on like a similar scale to n, it's between 1 and n. Uh, at the worst case scenario for these constraints, it would also be basically n squared times with 500 friends and a k of 500. So yeah, it's pretty slow. So can we think of a linear solution that can perform faster than that? Okay, so in order to find a linear approach to the problem, let's quickly run through one of the examples in the problem. So the first example given in the problem is a case where there are 5 friends and k is equal to 2. So let's just write it down like this. In my example, I will be using zero indexing because mathematically it's just easier to deal with. You'll see later why. But a basic approach, our simulation approach, would work like this. We would start from 0, we would go to 1, we would cross out 1, and then we would go to 2, 3, and then we would cross out 3. Then we would go to 4, and then 0, cross out 0, and then go to 2, 4, cross out 4, and finally we would end at 2, which would be our answer. The issue with this approach that makes it not a linear approach is that for each of the friends that we are crossing out, we would have to search through all of the available friends to find which friend we want to cross out. And the reason why is because every time we cross out a friend, we don't have any way to keep track of like which friends are crossed out. So let's say, for example, we have just these two crossed out, right? So we know we start from 4. We have no way of knowing if, like, for example, 0 is already crossed out, which in this case it isn't, but let's say we cross out 0 next. And then we have no way of knowing that we start from 2 because we would have to run through every single number for the friend, or like every single friend, to check if they're crossed out or not before we can get to it. And because we have to manually check to see if every friend is crossed out in order to correctly simulate it, that keeps it at like O of n time. So a linear solution would require a way for us to always know where the next friend that we have to cross out is. Immediately, one of the things that I see with this problem is that there's kind of like similar subproblems to each of it. Like there's kind of like a recursive slash DP component to it. So for example, when we go to 0, 1, and we cross out 1, the remaining 2, 3, 4, and 0, they're a lot like the original problem, but with 4 friends instead of 5, and with the same k, and starting at 2 instead of 0. So in fact, we can rewrite this to be equal to 0, 1, 2, 3, but like have these new indices be mapping to the old ones. So what I mean by that is like, so it always starts at 0, right? But in this case, 0 is referring to the 2 because after you cross out 1, you're essentially starting at 2. The 0 is going to map to 2. The 1 is going to map to 3. And then the 2 is going to map to 4. And then the 3 is finally going to map to 0. So here, again, we know that 1 is the friend to be crossed out. But when we're crossing out 1, what we're really crossing out is what 1 maps to, which is 3. And then we can continue doing this for each friend that we get rid of. So we do, let's see, 0, 1, 2. And then this would be actually 2, because you start at 2, and then you go to 3, and then 0, and then you would again cross out 1. So you cross out 1 every time. And then you go to 0, 1, but the 0 actually maps to 2, and the 1 actually maps to 0, and then you cross out 1 again, and finally you are left with 0 that maps to 0. So it's important to note that you're always going to be left with 0 because we're defining it as such, like as the first friend. But the way you would go from 0 to find out what the actual last friend is you would just follow the mappings. So you go 0 maps to 0, and this 0 maps to 2, which maps to 0, and then that 0 finally maps back to 2, which is our answer for 0 indexed 1. And then now the question becomes, how do we figure out in constant time what the mapping for each stage is? So let's first look at the mapping from like in chronological order. So essentially what happens is that each time you cross out a friend, the k plus 1th friend, so here would be 2, so like 1, 2, 3, so this is the k plus 1th friend, becomes the new starting friend. And every index is like shifted up by that, by k, or shifted down, I should say. So 2 shifts down by k, so it goes 2 minus 2 is equal to 0, and then 3 turns into 1, 4 turns into 2, and then 0, since it would become negative, if we subtract by 2, it wraps back around and turns into 3. And then we do this again and again. So for example here, we again have 2 turns into 0, 3 turns into 1, and then 0 wraps around and turns into 2. And then we do that again, and we get 0, 1, and then finally 0. So now the question becomes, is there a way we can like do it in reverse chronological order? Because we know what we start with here is 0, and if we have 0, is there a way to build back up and like revert and figure out like the reverse of these mappings until we get like our final answer? And the answer is yes. So earlier what we did was subtract 2 and account for like the overflow. Now we just have to add 2 and also account for the overflow. So what I mean by that is here we have 0. We can add 2 to 0 to get 2. And then here, since there's only 2 friends, we would mod by 2, and then that would allow the 2 to like wrap back around and become position 0. And then here we would just add by 2 again, and since there are 3 friends, 2 mod 3 is still 2, and then we add by 2, we get 4. 4 mod 4 is 0, and then finally we do 0 plus 2 is 2, mod 5 is also 2. And then we simply have to add 1 because everything's 0 index, while the actual problem is 1 index, and we would get our correct answer of 3. Okay, so let's go back to the original problem and code this up. Let's say we can call the value that we're working with return is equal to 0. And then we want to loop through all the sizes back up to n, or like size, let's see, 2, 3, yeah, I think for I in range 2, because we start at adding 2 and then modding by, or we start by adding k and then modding by 2, and then we end at adding k and modding by n. So we do 2 to n plus 1 to make sure we capture all of that. And then for each iteration, we want to do ret plus 2, or sorry, not ret plus 2, ret plus k, whatever k is equal to simulate shifting the index. And then we mod by I, whatever I is at that moment, to make sure that all the sizes, or like nothing overflows or whatever. So then after that, we just return ret plus 1 to fix the 0 indexing back to 1 indexing. And if we run this, yep, everything works. If we submit it, okay, good. We beat most people. But yeah, that is how you might go through the thinking process of how to solve this problem in O of n time and O of 1 space. And hopefully you found this video helpful, and I'll try to upload one tomorrow as well. Thank you.